H2 first, then H1, so that we can reverse the order of cascading. H2 followed by H1. സ്ട്രീം ചെറുതായിട്ടൊന്ന് ബ്രേക്ക് ആയിരുന്നു. അപ്പം ഞാനത് അടുത്ത സ്ട്രീം ബ്രേക്ക് ചെയ്ത് കാരണം വീണ്ടും ഞാൻ നെക്സ്റ്റ് ലിങ്ക് ഇടുകയാണ്. അപ്പോൾ ഞാൻ ജസ്റ്റ് ഒന്ന് വാച്ച് ചെയ്യായിരുന്നു എവിടെ വരെയാണ് കഴിഞ്ഞ സ്ട്രീമിൽ പോയത് എന്നുള്ളത്. എവിടെ വെച്ച് ബ്രേക്ക് ആയി പെട്ടെന്ന് ശ്രദ്ധയപ്പെട്ടില്ല. മോണിറ്റർ ചെയ്യുന്നുണ്ടായിരുന്നു, പക്ഷേ എന്തോ പെട്ടെന്ന് ബ്രേക്കായി കുറച്ച് ഭാഗം കഴിഞ്ഞിട്ട്. പക്ഷേ വിതൗട്ട് എനി ലോസ് ഐ തിങ്ക്, ബിക്കോസ് ഐ ക്യാൻ റിക്രെറ്റ്. ആദ്യത്തെ പാർട്ട് ഞാനിവിടെ വരച്ച് കഴിഞ്ഞു. ക്യാൻ സീ ദാറ്റ് ഐ ഹാവ് ഡ്രോൺ ദി ഫസ്റ്റ് പാർട്ട്. ഇപ്പോൾ ഇവിടെ പ്രീവിയസ് ഫിഗറിലുള്ള ആദ്യത്തെ പാർട്ട് എന്ന് പറയുന്നത് ഈ ക്വാർട്ടർ കാസ്കേഡ് ചെയ്യുമ്പോൾ റിവേഴ്സ് ചെയ്ത്, ഈ റിവേഴ്സ് ചെയ്യുന്ന സമയത്ത് ഇവിടെ ഈ കാസ്കേഡിങ്ങിൻ്റെ ഓർഡർ റിവേഴ്സ് ചെയ്തു. അതായത് H1 എന്ന് പറയുന്ന സിസ്റ്റം ഇതാണ്, H2 എന്ന് പറയുന്ന സിസ്റ്റം ഇതാണ്. സോ വി ഹാവ് റിവേഴ്സ് ദി ഓർഡർ ഓഫ് കാസ്കേഡിങ്. സോ H2 ഫസ്റ്റ്, ദെൻ സെക്കൻഡ് H1. So that this part comes first here. So I have drawn this part here. The second part is drawn again here as the first part. ഈ ഭാഗത്ത് റൈറ്റിലുള്ളത് ലെഫ്റ്റിലുള്ള റൈറ്റിലേക്കും ഇൻ്റർചേഞ്ച് ചെയ്യാം. ഓക്കെ, സോ കണ്ടിന്യൂയിങ് വിത്ത് ദി നെക്സ്റ്റ് സെക്ഷൻ, നെക്സ്റ്റ് ഡ്രോയിങ്. So sorry for the interruption because the stream was broken, and I am continuing again with the next stream. Sorry, just trying to share this on the classroom. അതിൻ്റെ ഒരു ചെറിയൊരു ഡിലേ ആണ്, ലാഗാണ് ഇവിടെ ഉള്ളത്. So let me talk that you don't feel that the class has stopped. Okay, so continuing, stream ചെയ്ത് കഴിഞ്ഞു. ഞാൻ ലിങ്ക് ഷെയർ ചെയ്തിട്ടുണ്ട്, ക്ലാസ് റൂമിൽ ലിങ്ക് ഷെയർ ചെയ്തിട്ടുണ്ട്. Now we can see this part, അതായത് interchanging left hand side and right hand side here of this diagram. So it is the cascading order has been reversed. So we have in the first diagram we have drawn H1 followed by H2. Now we can reverse the order of cascading. H2 first, then H1. Okay. So now next summing point. So from here we can connect to the previous summing point, so that you get the final output, capital Y of Z. So the Z transform of Y of n is capital Y of Z. So next we have delay element, that is z raised to minus 1. So z raised to minus 1, z raised to minus 1 gives you z raised to minus 2. So continuing with this, so the next one is B2, then output of B2 goes to the summing point. From this summing point we connect it to the previous summing point. So continue, etc. Then the second last value, Bm minus 1, Bm minus 1, then this goes to the summing point, then connect this to the previous summing point, then continuing the last value, the last unit delay element, that is z raised to minus 1. So you can see that this will be added. So z raised to minus 1, z raised to minus 1, z raised to minus 2, then z raised to minus 2, z raised to minus 1, z raised to minus 3, then z raised to minus 3, z raised to minus 1, z raised to minus 4, and so on up to the last value. So next last we have drawn z raised to minus 1, then this goes here to the next block, Bm, this goes to the summing point. This can be added to the, so all these summing points will be added so to the previous values, then you get the final summing here point here to goes to the final summing point. ഇത് നമ്മൾ വരച്ചു കഴിഞ്ഞു പാർട്ട്. ഇനി ഇവിടെ ഓർഡർ നേരത്തെ പറഞ്ഞ പോലെ it has reversed. So H2 first followed by H1. So let us plot this H2 first here. This is H2 and which is followed by H1. So H2 followed by H1. So we have reversed the order of cascading. So and therefore hence we can find that we have converted from direct form 1 structure. So this is the direct form 1 structure to the direct form 2 structure, where we can see that the z raised to minus 1, this can be made common. അപ്പോൾ ഇതിനെ രണ്ട് സെപ്പറേറ്റ്ലി വെക്കുന്നതിന് പകരം ഇത് കോമൺ ആക്കുകയാണ്. z raised to minus 1 കോമൺ ആക്കാം. ഇവിടെ ഇത് ജോയിൻ ചെയ്ത് കമ്പൈൻ ചെയ്തോ z raised to minus 1 കോമൺ ആക്കാം. ബാക്കി ലെഫ്റ്റ് ഹാൻഡ് സൈഡും റൈറ്റ് ഹാൻഡ് സൈഡും നമ്മൾ നോക്കിക്കഴിഞ്ഞാൽ this is same as the direct form 2 structure we have already obtained. It is similar to the direct form 2 structure already. This is the direct form 2 structure. So this is similar to the direct form 2 structure. So therefore we have converted the direct form from direct form 1 structure, the direct form 1 structure. So from direct form 1 structure we have converted it to the direct form 2 structure by reversing the order of cascading. So by reversing the order of cascading and implementing as two systems, we can convert direct form structure 1 structure to direct form 2 structure. Okay. So we can write the description here. It is figure 4. Direct form 1 structure after interchanging the order of cascading after interchanging the order of cascading. So we can show this by the following block diagram, how we have converted direct form 1 to direct form 2 using the block diagram, simple block diagram illustration. That is, we have input x of n, then the system with the transfer function h, which gives you the output y of n. Now here we can implement this as two systems, cascaded systems, with the transfer function h1 followed by cascading of h2, h1 followed by h2. So which again gives, so input is here again is x1, then the final output will be y of n. So ഇവിടെ x of n systemത്തിന്റെ transfer function, then y of n. So the system operates on the input function x of n to give you y of n. So here this is a single system. So instead of a single system, we can consider it as two separate systems with the transfer function h1 and h2, so that the total transfer function is h1 multiplied by h2. So here we can take h equal to, can consider the transfer function h equal to the product of h1 and h2. Transfer function h is equal to the product of h1 and h2. So therefore x of n is input signal. If you apply the signal x of n, you get the output y of n. Similarly, if you are applying x of n at the input of h1, after the final output we get, so after the output of h2, which is the final output, which gives you the final output y of n. So since this is cascaded and considered as h equal to h1 into h2, whenever you apply the signal x of n, you get the output y of n. And suppose we are reversing the order of cascading, again the result is same. So this can be shown that, further this can be shown that, to take again reversing the order of cascading, say h2 first, then h1, again gives the same result. That is, again if you apply the input x of n, the output will be once again y of n. So but here we have reversed the order of cascading. So now here h is equal to h2 multiplied by h1. Okay, so this gives you the final. So again this gives you the final output, which is once again x of n, input x of n, the system h, and the output y of n. So the implication is that whatever be the order of cascading, we get the same output. So the system can be considered, the system h can be considered as a cascade of two systems h1 and h2, so that where the transfer function h is equal to h1 into h2. So here now again the output obtained is same as that obtained in the system h. Okay, So now again, if you are reversing the order of cascading to h2 followed by h1, again once again h is equal to h2 into h1, which is same as h1 into h2. So once you give the input x of n, you get the output y of n. Again you are getting the same output. So here y of n is the output, same output here, again the same output. So if at all you are reversing the order of cascading, it doesn't make any difference. ഇതാണ് ഇവിടെയുള്ള implication എന്ന് പറയുന്നത്. Okay. So now next is cascade form of realization. The next structure is third one is cascade form structure or cascade form realization. So here the transfer function h of z can be expressed as a product of a number of second order or first order sections. So here in the cascade form of realization, we can express the transfer function h of z the transfer function capital H of z can be expressed as a product of a number of second order or first order sections. Suppose we have h of z, consider h of z is equal to output, which is y of z divided by the input x of z. So which can be shown as the product of say pi from I equal to I equal to 0 to k hi of z. So where hi of z equal to c0i ഇവിടെ സമ്മേഷനിൽ പ്രൊഡക്റ്റിൽ ഐ ഈക്വൽ ടു 0ക്ക് വരും 1 എന്ന് എടുത്തിരിക്കുന്നു, 1 എന്ന് എടുത്തേക്കണം. സോ ഐ ഈക്വൽ ടു 1 to k ആണ്. സോ പൈ ഐ ഈസ് ഈക്വൽ ടു 1 to k എച്ച് ഐ ഓഫ് z. സോ വേർ എച്ച് ഐ ഓഫ് z ഈസ് ഈക്വൽ ടു c0i പ്ലസ് c1i plus c2i term C1i z raised to minus 1 ഉണ്ട്. C1i z raised to minus 1 plus C2i z raised to minus 2 whole divided by D0i plus D1i z raised to minus 1 plus D2i z raised to minus 2. So this is the second order section. This is the second order section, now followed by the first order section shown by or hi of z can be first order sections, so which is equal to C0i plus C1i z raised to minus 1 whole divided by D0i plus D1i z raised to minus 1. So which is the first order section. So this is the first order section. So since this is a product, you can see that this is the cascade of system where pi I equal to 1 to k shows the product hi of z, so which is the product of h1 of z into h2 of z into h3 of z into h4 of z, etc. until the general term, that is k. When I is equal to k, we have hk of z. So when I is equal to 1, we have h1 of z. When I equal to 2, we have h2 of z. When I equal to 3, we have h3 of z, and so on, plus etc. Plus when I is equal to k, we have hk of z. So we can show this as a cascade of systems. And again, here the term hi of z is can be expressed as a product of second order terms or first order terms. So the second order terms section can be shown as C0i plus C1i z raised to minus 1, C2i z raised to minus 2. So since the power is 2, we can see this is the power is z raised to minus 2. We can see that the highest order is highest order can be up till the second order. So hence the second order equation section, and here this is only up to 1. So hence hi of z0 is equal to z0i plus c1i z raised to minus 1 plus d0i plus d1i z raised to minus 1. So here we have only up till the first order. So this is the first order section. Okay, so it can be realized either using second order sections or using first order sections. So the transfer function can be expressed as a product of a number of second order or first order section shown in this equation, that is h of z is equal to capital Y of z by x of z equal to product of I equal to 1 to k hi of z. So now we can draw the block diagram here. So write down the description. The individual second order or first order sections can be realized either in direct form 1 or direct form 2 structures. So you can use either direct form 1 or direct form 2 structures to realize. Then the overall system can be obtained by cascading the individual sections. ഇവിടെ h1 ഓഫ് ഇസഡ് h2 ഓഫ് ഇസഡ് എന്ന് പറയുന്ന ഡിഫറൻറ്റ് ഡയറക്റ്റ് ഫോം 1 അല്ലെങ്കിൽ ഡയറക്റ്റ് ഫോം 2 വെച്ച് ചെയ്യാൻ പറ്റുന്ന റിയലൈസ് ചെയ്യാൻ പറ്റുന്ന സ്ട്രക്ചറാണ്. ഇത്തരത്തിലുള്ള സിസ്റ്റങ്ങളെ ഈ ഡയറക്റ്റ് ഫോം 1 ഉപയോഗിച്ചോ അല്ലെങ്കിൽ ഡയറക്റ്റ് ഫോം 2 ഉപയോഗിച്ചിട്ടുള്ള നമ്മൾ റിയലൈസ് ചെയ്ത സിസ്റ്റങ്ങളെ കാസ്കേഡ് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് കാസ്കേഡഡ് ഫോം റിയലൈസേഷൻ കിട്ടും. സോ വി ക്യാൻ കാസ്കേഡ് വേരിയസ് സിസ്റ്റംസ് വിത്ത് ട്രാൻസ്ഫർ ഫംഗ്ഷൻ h1 of z, h2 of z, etc., h3 of z up till hk of z, and we can realize the cascade form of realization, and the realization is shown, how we can realize is shown in the following block diagram. The individual second order or first order sections can be realized either in direct form 1 or direct form 2 structures, the overall system is obtained by cascading the individual sections. So here capital X of Z, then the cascading shall be shown as H1 of Z followed by H2 of Z etc. up till Hk of Z. So there are several systems with the transfer function H1 of Z, H2 of Z, H3 of Z etc. up till Hk of Z, which gives the final output Y of Z. So this is what is meant by cascade form realization. So the description of the figure: cascade form realization of IIR system. The next is parallel form realization. So here the realization instead of cascading will be connecting the systems in parallel. So when you are connecting the systems in parallel, we say what is called as the parallel form of realization. So ഇവിടെ കാസ്കേഡിങ് ഒന്ന് കഴിഞ്ഞിട്ട് അടുത്ത കണക്ട് ചെയ്യുന്നതിന് പകരം ഒന്നിന് പാരലായിട്ട് അടുത്ത സിസ്റ്റം കണക്ട് ചെയ്യുന്നതിനാണ് പാരലൽ ഫോം റിയലൈസേഷൻ എന്ന് പറയുന്നത്. സോ വി ക്യാൻ എക്സ്പ്രസ് ദിസ് by parallel, by partial fraction expansion, the transfer function h of z of the system can be expressed as a sum of first and second order sections. കഴിഞ്ഞതിൽ ചെയ്ത പോലെ തന്നെ നമുക്കിതിനെ ഫസ്റ്റ് ഓർഡറും സെക്കൻഡ് ഓർഡർ സെക്ഷൻസ് ആയിട്ട് കാണിക്കാം. സോ ബൈ പാർഷ്യൽ ഫ്രാക്ഷൻ expansion, the transfer function capital H of Z of the system can be expressed as a sum of first and second order sections. So here h of z can be shown as h of z equal to capital Y of z divided by capital X of z, so which is equal to C plus sigma I equal to I equal to 1 to k hi of z, where the system shows a summation of several systems, say h1 of z, h2 of z, ht of z, h4 of z, and so on. So when I equal to 1, we have h1 of z. When I equal to 2, we have h2 of z. When I equal to 3, we have h3 of z plus a constant value c, constant term c. So where hi of z equal to c0i plus c1i z raised to minus 1 divided by d0i plus d1i z raised to minus 1 plus d2i z raised to minus 2. So this is the second order section. Since it has a power of 2, the polynomial has a power of 2, so we can take this as a second order section. Then similarly it can be realized using first order sections, where hi of z equal to c0i divided by d0i plus d1i z raised to minus 1, so which is the first order section. So now we can draw the block diagram representation, the realization of the parallel form. This x of z, then the constant gain block with the constant value c, then this goes to the summing junction, summing point, and from where we can take the output capital Y of z. And the next section is the parallel connection, it's a parallel block with the transfer function h1 of z parallel block h1 of z, then the output goes to the summing, another summing point, then this the output of this goes to the previous summing point. Then the next block or the next system with the transfer function, again this is connected in parallel. So remember that here the connection is parallel. So this is parallel to this, is parallel again to this, again parallel, we have several systems. So next this goes to h2 of z, and here this shows the connection goes to the summing point, then here the connection goes to the previous summing junction, then again this continues. So the second last term with the transfer function h of, and the output goes to the previous summing point. So okay, then again the last one, the last block, here we have the last block, which is hk of Z, and this goes to the summing point, and again the output of the summing point goes to the previous summing point. So this completes the realization of the parallel form of realization of IAR system. So this is as per the equation. So as per the equation shown here, that is h of z is equal to c plus sigma I is equal to 1 to k h I of z. When I is equal to 1, we have h1 of z, plus when I equal to 2, we have h2 of z, plus when I equal to 3, we have h3 of z, and so on. So c plus h1 of z plus h2 of z plus h3 of z plus etc. Plus when h is equal to I is equal to k, we have hk of z. So this is what is shown in the system. This is c plus h1 of z plus h2 of z plus h3 of z plus etc. plus hk minus 1 of z and hk, finally hk of z. So which is the output. So what was the figure number previous? Figure number was, it's not shown here anyway. So let me write it as figure itself. So this can be written as, description is parallel form of realization of IIR system. So here the individual transfer functions, that is h1 of n, h2 of h1 of z, h2 of z, h3 of z, etc. can be either realized using direct form 1 structure or direct form 2 structure. So whichever structure we can use it to implement h1 of z, h2 of z, h3 of z, and so on, and use these what's more is again to construct the parallel form of realization. ഇപ്പോൾ ഇതിനെ പാരലൽ, ഈ ബ്ലോക്കുകളെ പാരലൽ ചെയ്തുകൊണ്ട് പാരലൽ ഫോം ഓഫ് റിയലൈസേഷൻ നമുക്ക് സ്ട്രക്ചർ വരയ്ക്കാം. ഓക്കെ, സ്ട്രക്ചർ നമുക്ക് റിയലൈസ് ചെയ്യാം. So with this we complete this section. Let us continue with the next section about FIR systems. Thanks for watching the video. Okay, bye.